Welcome everybody to this talk and workshop on ChatGPT and the future of education. So I'm Jules White. I'm the director of Vanderbilt's initiative on the future of learning and a professor in computer science. And then I've got Charo Bell, if you want to.
Sure, I'm Charo Bell. I'm a senior data scientist at the Data Science Institute here at Vanderbilt. And I'm also the director of the data science minor, as well as an assistant professor of the practice in computer science.
And then also Jesse Spencer-Smith, who's back there as well and probably be jumping in towards the end. But Charo are gonna start off the presentation. Charo has some fascinating demos at the end, so please stick around for those because they're gonna be very exciting. And we're definitely excited to talk to you about what does the future look like now that we have ChatGPT. Before we kick off too much farther, I'm just gonna put up this resources slide at the beginning. We'll send out the slides at the end as well. And then Jesse's also got a bunch more slides for other opportunities for learning and education in this space, all kinds of different opportunities. We have the workshops in data science that are available, some papers that we've done on prompt engineering. There was a workshop last week on prompt engineering and ChatGPT for faculty, and that's on YouTube and available here. There's also a Coursera course that's free for Vanderbilt faculty and students on prompt engineering for ChatGPT. And a lot of the prompts and things that I use in this talk today come out of that course. So to get started, and let me get the Zoom controls. I pulled this screenshot today because I thought it was appropriate for sort of what it looks like, the landscape of AI today, and particularly large language models and these tools like ChatGPT. And so, you know, when Jane Goodall discovered that wild chimpanzees frequently make and use tools, you know, her advisor, Louis Leakey, famously quipped that now we must redefine man, or accept chimpanzees as humans. And I think we're at one of those moments in education where our tools are doing things that have fundamentally changed our understanding of what a tool can do. It's starting to make us question, you know, what is the difference between, you know, AI and human in all these different cases. We're starting to anthropomorphize, you know, AI. And suddenly we see AI doing tasks that we never thought that AI would be capable of, or certainly I didn't think it would be capable of in my lifetime. And now we have all these strange questions about how is this going to force us to reinvent how we teach, both from the perspective that these tools can suddenly do things that they could never do before. And we sort of assumed that students didn't have access to these types of tools for assessments, quizzes, and these types of things. But also our students are going to be going out into this world where they have access to fundamentally more powerful tools than we've ever seen. And we want to make sure that they are equipped to be innovators with these tools, because it's very clear that as we redefine what tools mean and redefine what it means to be human, all of these types of things, we're going to have to rethink their education to make sure they're prepared for that new world. And now, certainly not everybody shares this perspective, but I certainly believe strongly that this is going to be really important. And I want to give you some examples of this, of why I think it's going to be so important to, you know, rethink education to make sure our students are prepared for this world going forward, and also rethink how we can leverage these tools in the way that we teach. So I thought of what is the most exciting document that I could possibly demonstrate this with. So of course I took the Vanderbilt travel policy, because all of us work with the Vanderbilt travel policy probably at some point in time. And I'm going to just sort of contrast what tools looked like a year ago and what tools look like today. So a year ago, if you had a question about a travel expense, you could either go and read a PDF, that was sort of the state-of-the-art tool that we had at Vanderbilt, or you could email somebody to try to get the answer to the question. So you could email like your chief business officer or whoever, your financial unit manager or whatever, to try to get the answer about a travel policy question. But today, you can go and you can upload that document to a new tool that's connected to ChatGPT called ChatGPT Code Interpreter. And basically what it allows you to do is upload documents and begin interacting with those documents through ChatGPT. So in this case, I've just uploaded the Vanderbilt travel policy, the most exciting possible document. And I say, please read the provided document so that you can answer questions about it. So I'm asking ChatGPT essentially, or code interpreter, to read the Vanderbilt travels policy. And it goes through and it reads the travel policy, tells me roughly what's in it, summarizes it, which is pretty amazing. But we've had summarization in AI for a while. So what's really different about this? Well, the next question's different. So in the next question, I say, let's assume I'm in a foreign country traveling in a taxi and it breaks down on the way to an important meeting. Can I get reimbursed if I pay someone to drive me on the back of their motorcycle to the meeting? Assume they are a private citizen. Now, I don't think we had a tool in place a year ago that could read the Vanderbilt travel policy on your behalf and answer that question. But if you take the Vanderbilt travel policy and with a little bit of prompt engineering and put it into code interpreter, it can happily answer that question for you. It'll say, based on the information provided in the document, the key points relevant to your question are as follows. The university requires travelers to select the most reasonable and economical form of transportation. Non-conventional transportation options are not explicitly mentioned in the policy, so I think it's considering the back of a motorcycle non-conventional. And Vanderbilt does not have a separate policy on ride sharing or non-conventional lodging. The university does not endorse any particular provider of these arrangements and is not responsible for the safety of travelers, persons, or property. So I think it's getting at may not be the safest mode of transportation. And then it answers the question. Given these points, it seems plausible that in an emergency situation where no other reasonable and economical form of transportation is available, the cost of transportation by a private citizen's motorcycle might be considered an allowable expense. So 1 year ago, absolutely zero chance probably that you could go and just quickly upload the Vanderbilt travel policy and with very little work have AI basically answering, can you ride on the back of a motorcycle in an emergency situation? But you can do that today, and any student could do that today with probably any document that you have. So that's pretty interesting, but like, let's take that and see how much more sophisticated it can get in the reasoning. So a week ago, I did a presentation, a faculty presentation on prompt engineering for ChatGPT. And I took my slides, and I wish I'd done this before the workshop, and I uploaded them to Code Interpreter. And I just said, please read and summarize the key points on each slide, which it did a great job of. This is a listing of the first 5 slides, but it actually went through all 116 slides in that presentation. And then I said, act as a skeptic of everything I say in this presentation. Find flaws in my assumptions, assertions, and other key points, and then generate 10 hard questions for me. So notice this is a presentation. It's a PowerPoint that I prepared for a faculty level talk last week. And here I am uploading it to AI and I'm saying, hey, help me prepare for difficult questions regarding these slides. And here's what it says. Sure. As a skeptical audience member, here are some potential points of critique. Assumption: ChatGPT and similar tools will bring incredible increases in productivity, which is a statement that I make. Question: isn't it possible that these tools might also introduce new challenges and inefficiencies, such as the need for additional oversight or the risks of misuse? Assertion: everyone needs to be an expert in these tools to be competitive in the job market over the next 5 years. Question: wouldn't this assertion largely depend on the specific field or industry a person is in? Can you provide more context or evidence to support this broad claim? So it's, this is a human task. There was no tool that you could go to, up to probably a few months ago, that you could just upload slides randomly and arbitrarily and say, go and ask me hard questions, help me think and prepare for a presentation and question all of my assumptions. It's understood what my assumptions were. It's thought of which ones are important. And now it's giving me interesting hard questions. And so this is a human type task, right? This isn't a task that we think of as something that tools can do. And then I just went ahead and I said, well, if I'm going to ask it to give me the hard questions, I'm also going to ask it to help me think up different ways of answering the question. So I just say, generate 3 different possible ways of addressing each of these questions. And note, again, this is all based on my slides. And so this is an example with the first question where it says, isn't it possible these tools might also introduce new challenges and inefficiencies? And that was the original question. And the response 1, and it says, absolutely, like any new technology, AI tools can introduce new challenges and risks. However, the key is to develop robust governance and oversight mechanisms. And it goes on and it says, The third response is, it's not just possible, it's a certainty. However, it's also true that every major technological advance throughout history has brought new challenges along with its benefits. The key is to anticipate these challenges and develop strategies to mitigate them. So it's done a great job of dissecting my presentation, generating questions at a level that I think we would say is clearly human. And then it's also helped me think through potential responses to them. And again, this is what we call a tool, right? This is an AI tool. So the question that I began asking myself, the more I dig into these tools, is a tool when it creates its own tool to help get the work done? And I'm going to talk about what I mean by this in 1 second. But imagine if you're in your backyard and you've got a shovel and you're about to dig a hole. And right before you dig that hole, the shovel notices that there's a rock where you're going to dig. And so the shovel jumps out of your hands and it makes a pickaxe and then uses the pickaxe to break up the rock and then jumps back into your hands, and then you continue digging the hole. Is that thing still a tool or is it alive? It's really not quite clear, but we're having to rethink and redefine what it means to be a tool. And that example I just gave is reality today. So in that example that I gave you with Code Interpreter, when I said, please read and summarize the key points on each slide, and I provided it my slides in PowerPoint form from last week, Code Interpreter went and wrote a custom piece of software. Basically, it wrote itself a custom software tool in order to read the presentation. And it used that tool, extracted all of the text from my presentation, and then answered my question because it could not do it directly. So essentially, Code Interpreter is doing the equivalent of being that shovel jumping out of my hands, building the pickaxe, knocking the rock, and then jumping back into my hands. Like, it realized this is a PowerPoint presentation. I only work with text. It wrote a piece of software to extract all the text from the PowerPoint presentation, and then it processed it. So it literally created a new tool on the fly in order to help me accomplish my task. So the tool built a new tool to go and produce, to solve the problem. So before we go too much farther, one of the things we're going to talk about probably in this presentation is prompts. And I just want to ground that. So a prompt is basically the statement that you provide to a large language model like ChatGPT. So you might say, like, write a poem about the French Revolution, and that would be a prompt. And then it produces some text on the other side, or an image on the other side, or some other output on the other side. Or you might say, create a Pokemon game for my child. That could be a prompt. None of these are particularly good prompts, but they're examples of what a prompt is. So my belief, strong belief, which obviously we've seen it question this, is that the leaders and innovators in every domain over the next 5 years will be the people that are using generative AI. We have to be able to leverage these tools and be highly effective with them because they're transformational in capability. When you have a shovel that can jump out of your hands, build a pickaxe, knock the rock apart in front of you, and then get back in your hands so that you can finish digging the hole, that's a transformational tool. And it's going to have a transformational impact on education, the way we teach, what we teach, and what we need to focus our student skills on. And so my belief is that we've got to rethink everything we do, not to hold on to quiz questions, but to think about how do we live and work and operate in a world that has these sort of incredibly powerful tools, and what do we teach students when we're working with them, and how do we use these new capabilities to further our own teaching. So with that, I'm going to stop and hand it over to Charo.
All right, thank you for that. Let's see. I think I just need access real quick to share the screen.
Sure. All right, you should have access now.
Fantastic. Well. All right, so as Jules was saying, my name is Charo Bell, and I am a senior data scientist at the DSI. And as you have seen, these generative AI platforms are remarkable. Jules just showed us some excellent, amazing examples of things that we never would have thought would have been possible. And because of that, that introduces some interesting situations into our course design and into our courses. And so we're going to talk a little bit about how we can think about redesigning our courses if we want to more accommodate generative AI and leverage it within our courses now that it's here on the scene. So essentially, I will start with how we normally just approach teaching, the ways that we implicitly sort of do it and some explicit ways that we do it. And then we'll talk about how generative AI can affect your course just a bit. And then we'll introduce a framework that'll allow you to think and act about how you might go about changing the course. All right, so. So whenever we think about teaching and we think about the content of our courses, many of us tend to think about specific skills or topics or concepts or specific things that we want these students to know. So I come from computer science and data science. I'm thinking about certain data structures that I want the students to be able to command. I want them to know what variables are. I want them to know how to put these things together into a program to make them work. This is what I think of first. A second thing that we can also think about is exactly how much or what level of mastery do we want these students to have over these skills that we're talking about in our areas. So something that's interesting in the teaching and learning field is called Bloom's taxonomy, and it's a way of arranging the mastery levels of students from in the different areas. So in looking at this, we can see that clearly there are different areas relevant to each particular discipline. And this taxonomy was first established around 1956. It's to help with educational goals. It has gone through some different iterations, but we will just grab onto this one just to help us as a tool to arrange our thoughts on what we need to do. So what we have is we have this level where we just remember things, right? So we just need to be able to identify something. If someone sees a for loop, they can be like, oh, that's a for loop. Or they might be able to remember the syntax of the for loop. In terms of understanding, they might think about what the program or what these particular components are individually doing. When we get to applying, that requires a higher level of understanding where we have to think through the task that we want to be expressed through code, and then we need to actually make that happen. At the highest levels, which is the ones that we really try to get into as well as we can during our courses, is this ability to analyze and think about the relationships, critically think about the relationships between our code, the elements of our code, and how it fits into design principles like how to have code that is more maintainable, how to make it so that it's more optimized. And then we can also look at other people's code or look at our own code and think about how it could be better. What are the different techniques that we can use to make it better? And then we can just create our own as well, project-based designs for code as well. So we can see here that there's like this gradient of the level of mastery and expertise. And what we normally tend to think of learning objectives as is putting together specific skills with the level of mastery to express what we want students to be able to do when they exit our course. So we talk about learning objectives, also called learning outcomes. These are statements which helps to describe to students what students are to achieve as a result of taking the course. It also helps us as instructors, as you will see below in the following parts of the presentation, that it helps us to create assessments that are actually going to fulfill the purpose of the learning objectives. It's going to help us to strategize towards actually making these things a reality. And of course, it's helpful for students so they'll know exactly and understand where the course is taking them and what they should actually be able to do when they come out of the course. So then the question becomes, okay, we have these great learning objectives. And in the last slide, I just showed you an example of what some learning objectives look like. So then, of course, one of our jobs as faculty, as instructors, is to evaluate and assess if students are meeting these learning objectives. And we do this in a number of ways, again, relevant to the field. In our area, in computer science and data science, we might think about If we're just trying to get students to remember stuff, maybe they have in-class quizzes, quick assessments to make sure that they're understanding what's going on in the course. We want to have them to go more in depth about how things work together. We get into short answers, we get into essays. Usually these things end up being take-home assignments because students need a longer time to be able to think of them and leverage what they actually learned in class. We also think about projects as a main way to assess how students are meeting the learning objectives. And it's really very highly in this creative area when we assign them projects. If they're able to go from the initiation and go all the way through all the set of steps that we've taught them, apply those things to their particular situation and see the nuance of the steps that they might need to take to actually reach their objective. So we have a lot of different ways that we do these things. These are just a few that are sort of tried and true that we see all the time. And in general, we look at the quality of the work that they have produced in these endeavors, and we will grade it on this scale that reflects the level of their mastery of the learning objective. Now, something that we always need to keep in mind, and something that's very important when thinking about learning objectives and assessments, is the intentionality of how each question or each assessment moves towards measuring exactly the component of the learning objective that the student is mastering. So sometimes we tend to make these exams that maybe maybe some of the questions are not the best way to actually assess the learning objective, but they assess like some aspect of it. And sometimes that can be a consequence of the content of the course, like certain things that are very difficult to do, even though they're not a particular part of the course. And so what we're thinking is that through leveraging these learning objectives and thinking about assessments with very deep intentionality, really thinking about what are these assessments meant to assess, rather than what are we allowing them to assess tangentially right now. We can think also about how we might be able to leverage generative AI in our courses to help us actually better obtain understanding of how students are meeting these learning objectives. So now that we have this generative AI tool, so we see this ChatGPT, we see GPT-4, Bard, Claude, we see everything. We see all these tools that are widely available. This may actually influence how we choose to approach teaching and learning for our courses. So there are some things that we know, and Jules has showed us about with the generative AI. We've seen that it can take textual information, it can take slides, take some context, it can compose questions based on that context, it can synthesize information from information that you give it, it can create essays, pretty solid essays, code, pretty solid code, and they are actually pretty good outputs, particularly for introductory classes. Something else that we really notice about generative AI is while the systems are online, that can be a 24-hour, 7-day-a-week tutor for students. So when it's 11:59 and they're trying to email you at 11 p.m., trying to make that 11:59 p.m. deadline, it can assist them actually instead of them just not even being able to have a question answered. And they can use this generative AI at all hours of the day, any day, Saturday, Sunday, to better understand what's going on in their work and also help them to work through certain issues that they tend to run into depending on the course. Something that I really love about generative AI in particular is that it can help us to remove blockers in our courses. And what I mean by that is where we have these skills or techniques or things that we need to be able to do with one skill to achieve another. So if our purpose is to teach students to understand concept B, students have to first be able to do concept A to achieve concept B, but only sort of tangentially. So for example, in data science, it's often that programming is the tool which enables us to do these data analyses in a reproducible and a documented way. But the programming itself can be an impediment in actually being able to understand the data science process, what graphs mean or how to interpret them. Being able to actually create the graph becomes a barrier and a roadblock, and being able to understand and utilize those graphs. So it's additionally interesting because there are lots of coders, so a lot of people that are on deeply in the computer science spectrum who are not aware of data science techniques. And then on the other side of the spectrum, there are these people who are domain experts, and they're experts in data analysis. They know every single statistical method, every machine learning method, but they don't really have the programming expertise there. And so it often is the case that generative AI can lower this blocker between people who have this domain expertise and have the skill to be able to do the analysis if they could do programming with it. So when the purpose of the course is really to do something else, and it's through like another skill that is a blocker, that tool can be the blocker. And if generative AI can help us remove that blocker, then potentially this is a great way to leverage generative AI in our courses. On the other hand, though, we do know that there are some non-trivial concerns about using generative AI, which is that we know that sometimes it will just create information out of nowhere or just return as a response some next piece of information that it wants to predict, like a citation or a website that doesn't even exist. We also know that AI is a lot better at synthesis and putting things together in generation, as opposed to acting more as a knowledge database. So an important step, if you're thinking about revising your courses to accommodate generative AI, is to assess how you think or how you believe that using generative AI or the students using generative AI in your course will affect your course design. So this is an important step. I mean, we're already thinking about it. We're thinking, okay, you know, students may use this to write essays, they may use this to write code. When I would give them these assignments, they may use these tools to fulfill what I'm trying to measure as a learning objective. And so now that we know some of these capabilities of generative AI, we can think about how this tool will affect how our courses are running. So for example, in grading and assessment, if we were to assign many of the same exact problem sets or homework assignments or projects, we might find that generative AI is able to complete these tasks very well. Or at least they will form a really great basis for the student to build on. But in the case that they actually give the answer, particularly in introductory courses like programming, we can see that maybe these assessment methods might not be the best way to understand student achievement. And so honestly, this leads us to some like existential, like foundational questions about our teaching approach. So even thinking about if the AI can do these things well, okay, then we first get to maybe I should not be using these things like essay short answer as assessments. But in the past, I've always found that those things were really great at assessing student achievement. So now we're on the fence about that. Also, if we find that the student or that the AI can do these tasks and these assessments really well, then it also might make us wonder, to what extent does the student need to learn certain components of them? So, and thinking about coding once more, how well do they need to be able to write that forward? Do they need to be able to conceptualize what it needs to do, or do they need to be able to write the syntax from scratch? And so these are the questions that we start getting into. So then this leads to even more questions. I'm giving you every question in the world today, but we are finding our way to a way to resolve these things. So once we see how AI has the potential to affect our courses, then we just need to decide, is this something I actually want to use? Just because it's there doesn't mean you actually have to use it. You just have to think about, okay, what does it mean if I don't use it? And what misuse will be. Also, as we said before, what skills are actually needed? So what skills are needed when the students go on to their next course? And also what skills are needed when these students graduate and go on to their careers? If they have the ability to use generative AI in those situations, what exactly are the skills that we need to teach them in our particular courses? And lastly, as we've seen, the assessment in particular is challenging to think about. If the generative AI can do some of these foundational tasks pretty solidly, just through copying and pasting a prompt, how are we going to assess students, particularly when we have things like homework or things they do at home, like take-home exams, projects. How are we going to assess their level of understanding, particularly because those types of assessments we use when we're trying to understand a summative sort of assessment. So we're trying to understand their full comprehension of the full scope of what we have taught and how they're able to use it. So we run into some challenging ideas with that. Luckily, I think that we've developed some questions that you can ask yourself to sort of make your way through systematically, make your way through this complexity and think about how you're going to change your course if, again, you choose to do so. And so from the perspective of coursework, as we said before, we like to think about, these tangential learning blockers. So when I'm thinking about data science and students using coding to achieve their data analyses, there is a level where I believe that them learning how to walk through these debugging steps and experiencing that at length helps them with their critical thinking and with their problem solving. But is it in the way of the purpose of the course? The purpose of the course is to teach them data analysis. Is it appropriate for them to struggle so much with the programming that they don't actually make it to the data analysis in the depth that we would like them to have? So I think about those as tangential learning blockers. They're learning, but they're kind of tangential to the point. And if we have them, do we want to use generative AI to fix them? And if we do, then how is this going to affect my course? So if students now are not struggling with the minutia of coding, now what does that mean in terms of the content that I can introduce or the types of skills that I can introduce in my course? This also affects the overall learning objectives. So it could have been that one of the focuses of your course and one of the learning objectives was to write code literally by hand. Like you could write this code without assistance with high fidelity. If that is no longer your learning objective, then you need to ask yourself, then what is the appropriate learning objective for the course now that these blockers are out of the way? Do I need to change my overall course content? If not all of it, then what pieces? Once we get to the point that we're changing learning objectives and course content, then we think about what experience the students need to have to really leverage what you're teaching them in the class. So active learning techniques, how you're introducing content. Are you using generative AI in the course and in what way? What kinds of things there need to change? And then lastly, our favorite, how do our methods of assessment need to change in terms of the kinds of question asked, whether we want them to do it in class or outside of class, and what we are actually asking them to do. So this is a lot of questions, but let's walk through sort of a situation where we can begin to address these individual questions within the context of the example of a data science or a programming for data science course. So as we saw before, so let's assume that we have decided to adopt generative AI. Actually, what happens is we start at the beginning again of course design, because we're right back to reevaluating our learning objectives, but in the context of generative AI. So for example, we might look at these learning objectives. This is about being able to program, being able to resolve errors, understanding code blocks without running them, and then evaluating and refactoring code and understanding what the advantages and disadvantages are of certain limitations. So these might have been our learning objectives before. These are solid for even, pre-generative AI, these are rock solid. And so we may look at our learning objectives and they look completely fine still. We might even choose to add other learning objective. But perhaps what has changed here is the details of what any of these objectives truly entails. And it can be sometimes hard to think about that to determine what each learning objective really does cover and what it doesn't. So a colleague of mine, Dr. Will Doyle, introduced me to the concept of anti-learning objectives, which I found to be really helpful in terms of thinking about how topics will be balanced in the course, and also exactly like what each learning objective should lead to foundationally. So here we have the same learning objective that we had before. And then we have these anti-learning objectives where we can think about what exactly is it that we want the student to come out with. So are we okay with Like, is the goal for students to generate this syntactically and semantically correct code without any assistance? Or is it just being able to write pseudocode for the approach? Or are we fine with the student can, like, the only way that they can meet these objectives is to use AI assistance? Which one of these are we actually okay with, or something else? This sort of delineation helps to really inform the balance of what you will spend time on in your courses. For example, if the point is to be able to code without code without assistance, that will be a tremendously different set of skills and tasks and assessments that you use, as opposed to if you're going towards AI assistance only. So I think this is these anti-learning objectives really help me to nail down precisely where the balance is that I'm going to spend my time in the courses. So once we have this, it seems like we've really well established our direction. It's informing how we need to make changes. Then we're thinking about, okay, we're removing these blockers. We have new time. We have this new 24/7 support. We have these learning objectives. What do we do now? And it seems more that it comes down to a question of balance. So let's look at that. So for example, in our traditional classes that we might have had pre-generative AI, especially with these things that are learning blockers, we might have ended up spending more time on the lower levels of mastery. So we're getting students to sort of remember. We spend a lot of time in the application, because that is where the challenge kind of presents itself. When students are trying to apply what they've learned in class and they're running into these errors, like, this is where the challenge occurs. So most of our time is really just spent over there. We don't get as much time to spend on the evaluation or the creating. This is a balance that we can choose to change. So because we have this new generative AI, we can keep many of the same approaches that we already were doing. We can keep much of the same content, but now we're increasing essentially the mastery of that content that we're going to be focusing on. So now, instead of spending so much time on working through the minutia of fixing like the semicolon or what have you, now we're spending more time in analyzing the behavior of the code. We're evaluating what makes code good. We're evaluating what we need to have good analyses, and we are creating these analyses not just as a one final exam, but we're creating these analyses more generally. And also we're able, through generative AI, to critique analyses that it generates. And so built into using generative AI is an analysis of whether their approach that it has taken is correct. So I think that in removing the learning blockers, if you choose to use generative AI, one way to modify your course is just to increase the level of mastery for any of the given topics. Not sure about you all, but generally when we're teaching courses, there are some topics that we must teach, period. And there are other topics that we can get to, but the learning blockers really inhibit our ability to really make it through all of the content that we really want. And now, because we have the ability to remove these learning blockers through generative AI, we're able to now expand the amount of topics that we're able to cover. So we can move from just covering the basics and trying to get those hammered out to covering some of the additional tools and techniques that maybe people don't learn until very later on in their academic career or on the job. But it's more beneficial if they learn it earlier, perhaps in such a class as this. So without those learning blockers, we're able to provide more information, more topics. Alternately, I have also run into situations where I wanted to cover things more in depth. Again, because we have this extra time and because we've removed some of these learning blockers, instead of just spending time on just trying to power through A, B, and C, we can spend more time on the nuances that we might encounter with topic A. So, we have issues that relate to how you might do imputation, or we might be able to go into more information about hyperparameters or what have you. Now we're able to really delve into these topics at more depth, so that students have a really rich understanding of the foundational information that's in the course. Now we're down to one of our last questions, which is, how are we going to be modifying these assessments? Okay, So I think the core thing to keep in mind is the intentionality of the assessment. The assessment is meant to understand the achievement of the learning objectives and in the context of the anti-learning objectives. So for example, these assessments, we may change where we do the assessment. So we might change things from being in class to being outside of class. We might change the difficulty or breadth of different assessments, or we might change the weighting of some of our assessments in the final grade. So for example, if the generative AI can just go through and do a whole homework, then maybe that's something that's not weighted as heavily. Alternately, we can choose to have that whole homework that one might go through as something that we work together in class to sort of understand. And then we do something on top of that or assign something on top of that as homework. So generally in class, for some of our courses, we spend a lot of time on the lecture with guided examples. And the examples are just so important in terms of just resolving some syntactical and error sort of issues. We spend some time on group work and some on quizzes, and class quizzes are really nice, again, for assessing understanding. And then, of course, we have these in-class exams sometimes. And again, outside of class, problem sets, sometimes the final exam, essays, projects, that's what we're doing outside of class. But then if we might just make some changes based on, I don't know, what we find to be most important, the assessment mechanism, the type of assessment. And what we see is potentially we can leverage in-class time a different way. So we can do our regular lecture, but now we can actually add in this rich conceptual relationship building between topics that we might not have been able to get into before. So we might study for loops and we might study while loops, but we've never been able to really get in depth about how we might choose between them and what their differences are foundationally. We might not even introduce while loops in certain languages. We still will want to spend time on guided examples and group work, but maybe what we have here are a different kind of guided examples, different goals in our group work. And also we find that we might want to switch some of our assessments to actually being in class. So you might have an essay-based exam, but it would be in class as opposed to being something that you take home with you. Outside class, we might focus on things that the generative AI is not overly amazing at. So for example, we might choose to give something that has a lot of information that's associated with it, a very expansive project with lots of components. Maybe the students will be able to use generative AI to help them with this, but it will be likely that, or the goal would be that they can use it to start them, but they would need to engage with the material from the course to actually be able to complete the entirety of the work. You can also choose to explicitly factor in generative AI into your coursework or into your problem sets. So instead of asking more simple questions, you can ask those same simple questions and ask the student to interpret it, or you can ask them more challenging questions. And again, we have this opportunity because of generative AI to discuss things that it creates, and we're able to critique and get to those higher levels of Bloom's taxonomy. Also, one last point is that I think people are a little bit hesitant about integrating in generative AI. Some people are, some people aren't. But I think what's really nice about the assessments is that it opens up this door for student creativity. So what I mean by that is I saw a video the other day of this student trying to explain to someone else how the earth revolves and its relationship to the sun. And so they said, you over there, you're the sun and I am the earth. And then they turned around once and like, that's a day. And then they walked around the other person, they're like, that's a year. And I think that kind of assessment is just so interesting when I'm thinking about how we can assess students. So not just things that they write down, but things that they produce based on their own interest and what makes sense to them. You know, they say a picture is worth 1,000 words. So I think the way that students can demonstrate their understanding is much more expanded by the use of generative AI. And I think that's about it for this work. I hope that you found that at least somewhat informative or as a basis for which you can think about course design if you so choose. Again, what we recommend is just think about where generative AI is going to impact your course and whether you want to use generative AI to impact your course in that area. Understand your learning objectives, and anti-learning objectives can also help you to clarify this. Then just determine how you're going to rebalance your content, whether you want to cover more topics, cover topics more in depth, and then how you're going to change your assessments to reflect that. And now I will pass it on to Jules to give us more examples about generative AI.
Yeah, thank you. So I'm going to get my screen shared here. All right. So I'm going to just start off with some very sort of basic and easy use cases of ways to use it in a classroom, and then try to go into some of the more exciting and sort of advanced, I think, potential that it has. So a simple way is just all of the sort of brainstorming and content production around classes. So you may be able to, if you're going to teach a particular topic, you want ideas on different ways to approach or structure the topic. I've talked to people who are using it to generate lesson plans. So give me 10 different lesson plans to go and present this particular topic, or 10 different lesson plans and have each one focus on different aspects in order to, do different types of brainstorming for a faculty member, being able to generate different examples for your students. So be able to go through and say, give me 10 different examples of abstraction in Java programs, or give me 10 different examples of, metaphor, or whatever it is that you're wanting to do. You can really quickly go and generate all of these different things. But you can also go do advanced things where you do sort of like personalization. So this is an example I give in a lot of talks where I worked with ChatGPT, and basically I get it to generate a Pokemon game for my son that quizzes him on division with fractions and nutrition. Now, and then basically it goes through and dynamically generates the questions and interacts around these concepts. So if I'd had to go from scratch and try to generate questions around Pokemon, division, fractions, and nutrition, there's no way I could have done it. And I certainly couldn't have come up with an endless source of them. But if you go into a tool that uses generative AI like ChatGPT, you can instantly sort of create these sort of sources of examples, questions, assessments, all kinds of things. And you can also personalize them to the interests of individual students to try to make it more engaging. And I think we've seen a lot of that type of stuff. Some of the things that are getting me more excited lately about, I think, potential uses. One that really resonated with me was when I took my slides and I asked it to be a skeptic of everything I said in the presentation. And it started giving me feedback on my own presentation and making me think about the statements I was making, the assumptions I was making in there. And I thought about how often we give students assignments to go and produce work, and there's this long feedback cycle before they ever get any response to what they're doing. And is there a way that we can fill that gap? When they go and do some work, we allow them to use these tools to get quicker feedback and improve and iterate on their own work themselves by having it go and give them feedback about areas to potentially improve, or question assumptions or things that they're making in their writing or presentations or their code, and try to have them think more deeply about their work, refine it, and iterate multiple times before they ever come and turn it in. Because a lot of times, they struggle through to create the first version, and then they're just so, they've seen it in one way to solve the problem, one way to think about it. They have trouble going and self-assessing. So I think this is some huge potential here to use it as something that they go and get feedback on their work and iterate multiple times before they actually turn it into an instructor, help them improve the quality of their own work. I think another one that's really kind of interesting to me is this idea of trying to think through what a student in my class might struggle with in a given presentation or in a given topic. So sometimes, what I think they're going to struggle with may not actually be the case. And so you can go and do kind of amazing things where you say, for example, act as a struggling student in my class, listening to my presentation. What are the concepts that are going to confuse you, that are going to be too timid to ask questions about? What are the questions you wished you'd asked? And I give it my presentation. And then it goes and says, well, generative AI models, can you explain in simple terms how a generative AI model generates or creates new data? What's the main difference between generative and discriminative models, and why does it matter? And these things are things that I don't explicitly, cover in my presentation. So I could see students struggling with them, but also just getting a sense of like what my students have trouble with, what am I not covering? What am I not talking about in detail? And helping to understand different ways of looking at it. This could also be tailored to, if I go back to past, quizzes or assessments, and I took that data and I fed it to ChatGPT and I say, okay, here's how, the class as a whole performed on different topics in the past. Here's the presentation I'm about to give. Where are the areas that they might struggle with based on that history? So I think there's a lot of potential there. One of the things that I see with students a lot of times is that they have trouble thinking of multiple ways of solving a problem. And so they kind of get zeroed in on solving in a particular way, and they're not used to trying to expand the scope and think of multiple ways of solving a problem before they get started. So this is a simple example that I went to when I needed to figure out, how do I, for these workshops, come up with a way that faculty could register for them, and then I could send out Zoom links at the end. So I just went and asked ChatGPT code interpreter, and I said, I don't want to spend any money, but I need to have a mechanism for managing registrations and sending out email notifications with the Zoom link for the workshop. Give me 3 different approaches for this process and reference specific tools that I could use in the workflow between them. And it basically went and generated 3 different ways that I could solve this problem. But you can also give it other problems. Like when I talk about doing coding in my class, I could say, what are 3 different algorithms to solve this? Or 3 different approaches for writing this code, and discuss and give me the differences of them. So helping students to see through different ways of solving problems. Another way that I think people talk a lot about the mistakes they make, but I think the mistakes they make are also a learning opportunity, in a way that we can motivate students that they can't just rely on these tools, but also create sort of interesting assignments for them. So the example I give of this is, you imagine you give your students and you say, here's a ChatGPT prompt that I want you to use. So like, please use this ChatGPT prompt to generate an answer for this question. And then you have to go and assess its accuracy, right? You could try to use ChatGPT to assess ChatGPT, but you're never going to get anywhere, right? So you say, go use library resources or something fundamental that could be checked outside. So for example, I gave it the question, can you speculate on how computer science would have been written in Babylonian cuneiform? And it goes through and it basically says, to convey the notion of computer science in Babylonian cuneiform, we could break it down into 2 components. Computer, the concept of a computer as we understand it today, did not exist. So we can approximate it by referring to the concept of calculation or reckoning. Science, the Babylonians had a keen interest in science. So we could say, we could use the cuneiform sign for knowledge or science. And then it spits out what's possibly cuneiform, but I actually have no idea if this is correct or not. So if you were a student and you wanted to turn it in fact checking this exercise, just say, okay, here it is. Go use library resources and try to solve the problem of figuring out, is that cuneiform that got spit out accurate or not? Is it just a hallucination? And that becomes a deep assignment where they're then having to go and figure out, like, how do I assess the accuracy of something like this? What library, what real resources, what tangible facts could I use to actually try to solve this problem? Another one I think that's really interesting is to think about experiences where we use the fact that it makes mistakes and use real world problems that we need solved that can be checked for correctness to build sort of immersive learning environments. And so you can imagine sending students into a lab where you have a bunch of physical components to build a robot. You might have like 3D printers to print parts. You might have like wheels. You may have electronics. You have all this stuff and you tell them, okay, I want you to build a robot. Here's the starting prompt you're going to use with ChatGPT. And the starting prompt is something like, I want you to help me explore a virtual lab for building robots. Help introduce me to the lab and what I can do here. And then they have to get from that point in the physical components to an actual built robot by interacting with ChatGPT. And if it hallucinates and they go and try to build it, they're going to discover very quickly that it was wrong. So in this example, I just went through it and it starts walking me through and describing what I can do in this lab. It's saying like, you can design robots, you can test robots, you can program robots. And then I just say, hey, can we design a robot together? And it says yes. And it says I have to tell it certain things like the purpose of the robot, concepts, necessary components. And I tell it, okay, I want to build a robot and I want to go through these things one step at a time. I'd like to 3D print parts, have a circuit diagram, and have code that I can run on the robot. Can you help me with that? And it says, sure, and it describes all the steps that we're going to have to go through to do that. And I keep going through with it, and I tell it I want to build a robot that follows a line on the floor. And it describes, okay, I still need these additional questions to follow up on. And what's kind of interesting is each time I ask it to help me, it's drilling down in sort of levels of detail and design that I have to start thinking through as a student of like, well, what do I want it to do? How am I going to get it there? And helping to sort of guide the process. And so I keep going down this, and I get to the point where I actually have it pick electronics for me for my robot, and it gets down to the point where it's actually picking real physical electronics, which I fact checked these with some other faculty members that these are real components. And it gets down to the point of having real components that could potentially be assembled, drawing circuit diagrams for me of how they could potentially be assembled. And then even going to the point of generating code that based on this microcontroller board that it picked, which was an Arduino, it actually then gets into the point of actually generating code for the Arduino that then you could go and run on it. So you could imagine taking students in and having them go through and do these sort of virtual immersive experiences. The other thing that I think is really sort of powerful is at any point in time when you're having a student work on a particular topic, you can instantly generate sort of quizzes on arbitrary combinations of material. So in this robot example, I got to this point where it had gone through this whole process of building a robot. And then I just said, okay, quiz me on everything we did with the electronics. And so it instantly turned it into a quiz related to the concepts that we had just covered in the building of the robot. So we'd gone through this process. And then at that point, it turns it into an assessment to help me gauge my knowledge of what we've just done and test it. You can also do really incredible things with gaming and simulation, and there's been a lot of discussion on this on the internet. I'm not going to go through this entire prompt in its entirety, but basically what this prompt is this is a prompt I'm going to use in my cybersecurity class that's allows me to do something I never could have done before these tools existed. And basically what I tell ChatGPT is we're going to play a cybersecurity game, and you're going to be a Linux terminal for a computer that has been compromised by an attacker. So basically what I'm telling it to do is to pretend to be a computer that's a victim of a cyber attack. And then I tell it basically, I'm going to type in real computer commands to you, and you're going to respond with exactly what that computer would have done. And it can go through and simulate exactly what that computer output would look like and explain everything based on it. So it'll go and explain a story to me about how I'm investigating these incidents on this computer. And then I'm going here in this ls-alt is a real command that you can run on a computer. And it's then dissecting it, explaining the command to the student. And this is a real thing that my students struggle with, is knowing these commands and learning it all. And then down here beneath it is the actual output that you would see on a real computer. It's correctly formatted and everything. And it has certain key files, like this bash history file here is a key file that you would want to go and look at if you were on a computer that had been the victim of a cyber attack. So it goes and can generate simulations, but you can go and say, generate a game based on this, event in the French Revolution, and here are the rules for the game, or you create the rules, and it can, come up with games, and you can go and play them interactively, or it can help you design and do all kinds of interesting things outside. So what should we learn? This is one of the big things. It's just text, right? Well, no, we need to learn prompt engineering to do a lot of this. So if you didn't come to the first faculty workshop, I'd encourage you to take a look at the link to that. But also, if you want to go deeper into this question or point students to deeper in this question, we have a Coursera course on this. That's about 87,000 people to date. And this is free for Vanderbilt faculty students to take. We also have a paper that dissects a lot of these prompt patterns that Jesse and I and some other collaborators put together. And if you want to find it, you can also go to Google Scholar and search for prompt engineering. It's the top thing there. And prompt engineering is basically how you structure all these statements. How do you learn to tap into all these capabilities to do interesting things? And then we've got a whole bunch of faculty workshops on these topics that are coming up. I think I'm also now going to turn it over to Charo, who's going to do some live demos of some example sort of advanced tools that they've been building out in data science to support learning.
All right, thank you very much. And as you know, live demo time is always a fun time. So let's just take a look. Let me share my screen right quick. Maybe it's not this one. Okay, so first I would love to tell you about let's see if I'm a suite of tools that we're currently calling class, which is correctly named. This is the repository, and so this is where all of our code is. Currently, this is closed source, unfortunately, so it's a private repository, but at the end of the summer, when we're done developing, this will be an open source project for other people to contribute to, other people to use, and other people to extend. So we're very excited about this. Let's talk a little bit more about it. So what we have is this suite of tools, and they're meant for people at various levels of expertise when it comes to programming. First, we have prompting guides. So that basically means if you want to just write some prompts and use something like OpenAI or Bard, you can copy and paste these prompts into those chats, and we'll be able, and these prompts will do exactly what they say that they will do. And so we verified these on specific models that were available, and so we've seen that these are working really, really well. So some of these prompts are about learning objectives and actual self-study, but other prompts are about how we're going to submit things to instructors. So someone asked something about grading a second ago. We'll talk about that a little bit more. So let's see. So we again have these prompts that we're able to provide for people who just want to copy and paste a really well working prompt into another interface. The second level of work that we have is these interface driven programs. And so we've created our two posted exams. They're on Hugging Face. And what happens is these links will go to, they will go directly to what we're looking for. So those programs. So one of them is specifically about self-study. So it's about being able to upload text, upload your own text, upload instructor text, and being able to engage with it. And we'll see that in just a second. Lastly, we have these really nice Google Colab notebooks, and these are for the people who are sort of in the in-between. Maybe they want to be able to modify the code that they're interacting with, or maybe they want to do something specific or use it as a basis for building in a course, or maybe instructors want to use this, again, as a template to start students learning how to use generative AI. These are really great for that. Additionally, this platform is not just for students. So we love self-study and engaging with these topics, or engaging with the course materials. But what we have also provided is a set of notebooks for the instructor. So what they have is the ability to go on a website and take all of the information from a website and put that into some storage, or go to some YouTube videos and take that as content if you have those, or if you just have a set of PDFs in Brightspace, you can use that also as the content. And so what will happen is you'll make something called a vector store. It's just a fancy name for something that has all of your documents in it, and it's easy to reference. And you'll create that. And again, the instructions are right here. After you created that, that means you have all of your teaching materials essentially in one place. Exciting. And now your students can actually use that, the link that you will have within their notebooks or within the user interface to directly reference your course materials. So let us take a quick look then. We can start then at the beginning. You can see like a lot of notebooks here. There's a lot of ways that you can use this, but let's start with prompt with context. And some of these I have already started running because some of the installations are not the shortest. But this notebook has to do with basic interaction through Google Colab with prompts and with generative AI. So looking at this, the way we run it, we just select the ones that we want, and then we click on Open in Colab. When we open in Colab, we see the following. So this is a notebook that's actually in a runtime that we can run from top to bottom. You can see that I've already run a few of these things. So here we see how so again, this is really great if you want to be able to use this as a basis for something, or your students to build upon it, or they just want to use it. So here we have any installation here, all the generative AI, this is how we're setting it up. And then we have the area where we're actually starting the self-study. So here, this is the notebook that is specifically about using copied and paste content. So if your content is a little bit shorter, so you would give this to the student would just copy and paste it in here, and then they will need to add whatever query that they want. So what we have done here is provided, again, a set of prompts to help them with actually doing the prompts and getting good answers. So here we have the context, and here we have some queries that we're starting with. So now what we have, again, is a guide down here. So our guide is describing the different prompts for interacting with the model. So here we have the 5-question quiz, and this is just an example to show how this works. So we want a 5-question quiz from this context that we provided. We are actually inputting the learning objectives that are provided by the professor for that particular assessment or for the course. And then we are asking for exactly what we want. So what we want actually is to be prompted one by one. So we want 5 questions, but we want to ask the model to ask us this question one by one. So all we do is run this. We didn't need to do really anything special. What it's doing right now is sort of just what it looks like. It is sending this prompt over to OpenAI, to that model that we specifically referenced, and using that API to get this particular answer. And so this is the response from the model. And so now we can see that we can use such a setup for within Colab. And so we see a lot of actually different ways that we can interact. We have some short answer questions. We have some fill in the blank questions that help us to self-study. We have things that we want to put in order, even though that's not really making sense here. We have some relationships that we can see here, and then we can also explore some concepts and definitions. So we have these prompts that are available. You can use them directly in Google Colab once the repository is released, probably later this summer. All right, so that is the most basic way for students to interact with the model. Then we have the user interface that we talked about. And so we're going to take a look at that now. This is the Google Colab version of that. And again, I got this one started because the packages, they can take a second to get installed, and we just want to run on past that. So here, if you wanted to run it, you would go to Gradio application, and you would do the same thing we just did before. We click on this, and then we open this here. Also, there will be a live link to the actual Hugging Face, space. So you don't have to ever run anything in Colab. It's like you go right directly to the site, and then you're able to use it directly, or your students are able to use this directly. For this one, as we've said, we're kind of in a pre-alpha stage, so always a wonderful moment of errors. But this is essentially the code. You don't need to look at any of this at any time. You just run it from top to bottom. And so in the end, what we get is something that looks like this. And I'm just going to go ahead and click on this so you can see the entirety of the user interface. So this is the general user interface for students for self-study. So one thing that your students will need will be an API key for OpenAI. And what we do is we'll just paste that on in. And then we're going to upload whatever documents that we're wanting. So one, you can see that we can copy and paste any text like we just did with prompt with context. We can drag and drop or click to upload. And also we're able to use a vector store that's provided by the instructor that we just talked about. So when you have all your course materials in one place, they'll just have a link. So let's look at that. I am going to upload, let's see, this should be a familiar paper. It's a prompt pattern catalog by 2 people who are in this meeting. So we're going to self-study on that. And then maybe what we want to do is input our learning objectives. So we might want to understand the benefits of using certain prompt designs over others. And then, I don't know, the pitfalls of problems encountered, something, whatever have you. So these are our learning objectives. And then it depends how you want to interact with the model. But we also have this area for pre-made prompts. So let's say your students get here and they're like, I don't really know how to self-study. They can pick from some of the regular types of questions that are asked. So maybe short answer. We might have, hey, ask me 5 questions. Maybe I want to respond in a more essay-like form. and then it's going to help us to generate that prompt. So we're not writing this prompt on our own, even though we can. So here it generates the prompt for us based on this prompt template that we've seen that works. And then what we can do is we can just directly use this prompt. So we can insert the prompt into the chat here. So that's where we kind of let the user interface help us. Or we could have not done that at all and just added our own question here in the form of how we interact with OpenAI. So let's see. So here we're going to have a little error moment, which is always exciting, but you can see the basic design of how this is working. Essentially, we have this chat back and forth, which is using the context, and it is using exactly our prompts. And currently, what it can do is not only get an answer back and begin this process of iteration, but it also provides the sources. Sorry, just a second. I just realized that. Okay, there we go. It provides the sources where it got the information from. So currently, So what it means by that 1 and that 2 is that it's pulling from, you remember when we were talking about the vector store? It's pulling from specific components of the vector store to generate the question. So I know that we have talked at length about hallucination, and that scares us. We also want to make sure that at least the model is generating something based on some sort of sense. That is what will be shown in this box if we could, get past pre-alpha. And so again, this will be something that's more ready at the end of the summer. So after we finish our conversation with the model, again, we're going to have this back and forth, a 5-question quiz. After we're done with that, maybe a portion of the point of this is that you as the instructor get feedback from your entire course of students on how they have engaged in self-study with this model. So maybe you have some questions specifically that you want them to answer through interacting with the model, or you want to see what kinds of things that they're exploring through working with the model. If that's the case and you assign them to go and use something like this or any of the Colab notebooks, then what they can do is export in a particular format and then upload that to Brightspace. Okay, so that's interesting. That's an interesting point. So now we're able to self-study from a variety of different sources. If you assign that as an assignment, they can download this set of information as a JSON or whatever format they want, and then upload this to Brightspace. What does that mean then for you? Exactly what you would think. Maybe you want to be able to grade this set of assignments. So let's see, in that moment, what you could do is use our instructor notebook, and it is about grading. And so here you would do the same thing again, click on this. And then we open in Colab and you'd be right here. And then again, all you need for Colab is actually just a Google account. So here we are in this notebook. This one in particular is meant to sort of hide some of the code complexity. So we can just run this thing. We'll start by running these because it tells us to, and then let's run this container. All right, so here we might want to input our learning objectives. That would be nice for me to copy and paste from the other one. Yes, wonderful. Actually, I'm not going to do that because it's going to go. Anyways, so I'm not sure. Learn about the topic of information. So that's kind of just like a space filler. And now we're able to actually upload the files that we were after, right? So again, all the students submitted their files on Brightspace. We're going to download all of them as a zip file. So here's a zip file. It has all of my students' results in there. And so now we can see all the files that were in there. So we can just make sure visually that it's making sense. And then we can input our OpenAI key, which you will again need as an instructor. And I would love it if this was stored, but maybe it's not. Okay. There we go. So then we're actually going to do the grading. So here, this is a little bit of setup that you don't need to see unless you want to and do the modifications. And then we can actually get into the grading component. So let's take a look at that. I'm actually going to run all of these below. So what has happened? So something interesting that happens is students can sometimes find a way to somehow have, or the model will output like some weird sort of JSON sometimes. And the point of this is so that we just don't error out. You can ask the student, hey, can you go back and regenerate this? These are what the problems are. So we see with this particular file that someone generated, then there's something wrong with the way that they outputted their JSON. And the same here, it's just these keys are not correct. And what we again have done is provided a prompt that works directly with this. So here, we also like to allow flexibility for the instructor. So this is a prompt that will allow you to just do this preliminary grading. What is that grading point? So here, we are trying to get the summary and detailed feedback for each of the students' response, what was done well and what was done poorly. So this is something that you might be interested in, but you can see it's literally written here. This is something that you can change. And then we might want to add some grading instructions, which we may or may not utilize. So here, this is just some code that makes this possible. Did I already run this? Yeah, I did. Whoops. So now what it's doing is it's iterating through all of the student submissions. Here, maybe the student did not follow directions. And in what way did they not follow directions? They did not provide any context for their answer. They did not do something that was useful. And you can see all of that here. Maybe you look at a different student, and we can see that actually we have more feedback for them. So they answered all correctly, but then we also see some more details. So they understood the differences between stacks and queues, and exactly. So here we have exactly what we wanted, and we have these final point added. And so now we actually have done a first pass of grading. So we don't really consider this to be the final grade. The final grade always has to be resolved by the instructor, but this is something that can really help. It provides these insights and also a few prompts to help you. If you wanted to insert your own custom grading here instead of the previous area, you could do that. We have also looked at Bloom's taxonomy as a method for just a default sort of rubric to understand the way that students are interacting with the models. So if they're asking them for like, or if the students are asking to be assessed based on definitions, so help me, do a quiz with me to help understand like the jargon of my field, then they would get like a 1. Or if they are supposed to be like summarizing some key ideas, then they would get a 2. And so that is another way that we can evaluate. And then finally, what happens is we're able to write these all to a JSON file. You can see that here. And this is the full evaluation log. You can see that it's given for each student. And what this is meant to do is allow you to quickly go into Brightspace and copy and paste for each student to give them feedback. A second iteration that we will do after this is leverage Brightspace's API to instead automatically upload the detailed feedback and the summary feedback. And currently under development is the prompt, which will allow the model to look over the entire expanse of the student answers to determine what in general was missed by the students, what they didn't ask and what they asked a lot about. How does that help you as an instructor? Because you can spend more time on the things that were unclear to the students and then spend less time on the things that were clear as day. So this is something that can help you grade. Again, we are help you grade as opposed to giving the final answer. But this is another way that you can interact with this platform. So I think those are the main points. Takeaways are that currently we're still pre-alpha. We expect to have this probably near the end of the summer, very beginning of the semester, ready for public digestion. And if you have students who are, or you are a student who's interested in extending this, we would love that. But this will be ready for you about that time. And I will pass it on to Jesse. And Jesse, you might be muted.
So do want to point out that we have other resources for you as well. And so wanted to put those in there and then I'll open up for any questions that you have. But did want to point out that we're going to be having additional workshops all throughout the semester. We're going to have workshops that are specifically This was a question in the chat for folks in the humanities, for folks in experimental sciences. So we're going to be having workshops that are going to be very specific for different areas of study. The way to find out about all of these is to sign up for our newsletter, and we'll be sharing this with you as well. But it's bit.ly DSI newsletter, or you can take a quick snap of that and sign up for our newsletter. I'd also like to point out that you can sign up for a consult. So if you are interested in these tools or interested in exploring further how you might apply some of these tools and techniques to your particular class, you can sign up for a consult. So again, it's bit.ly DS team that will get you directly to us as well. And you can sign up for time either individually with any of our data scientists or with Charo, me together to answer any questions that you have. And finally, I'd like to let you know that we do have AI Fridays. So on AI Fridays, and this is really from 10 to noon, we have drop-in time. So you can just stop by, and this can be anything from thinking through, brainstorming, coding, models not, your prompt isn't working the way that you want it to if you would like it to work, you can drop in and spend some time with us, and all the DSI data scientists are there to help you answer your questions. So we'll be sending this out so you have all this information, but we're going to be beginning those drop-ins on August 25th. It's going to be every Friday, 10 to noon. Jules, shall we open this up for questions now?
Absolutely. Yeah, so feel free to put questions in chat or come off mute. Or if we don't have any questions, we can also wrap up. All right, well, if we don't have any questions, thank you everybody for attending, and we'll be sending out a link to the recording afterwards. And then of course, if you have any questions, please don't hesitate to reach out to us. Thank you.